Okay, let's solve this problem. Here we are supposed to find what's the current I. The current I here flowing through this branch. So this current I is the sum of these currents coming here, right? So this 1 ohm resistor, what is coming through 1 ohm, and the current coming through this branch of 8 volts. If you add both, you'll get I. Alright. So let's try to do this. We can consider 4 meshes and solve, but it's going to be a lot complicated, correct? So there's one simple way of doing it. These are all ground, right? This is a ground point. You're going to assume this is ground point. So this is all at 0 volts. So where the 0 volts will be 0, 0, 0. There's no drop at all. So 0 volts everywhere. Everywhere 0 volts. Here also 0 volts. Okay, till where there's no drop, we have 0 volts only. So now we know these are all at 0 volts. Fine. Okay, so we can redraw with this. We can redraw the circuit with this ground. Okay, that means what is 1 amp source is connected directly to ground. This 1 ohm resistor is also connected directly to ground, and this 8 volt is also connected directly to ground. This 1 ohm is also connected directly to ground. This 1 ohm is also connected directly to ground. This is the thing. So with this understanding, we can redraw this little better. So let me draw the current source here. Start with some point, right? I'm starting with current source. There is 5 ohm resistor in series with the current source. This is 1 amp current source. Okay, so that's connected to some 1 volt and then some point. So let me call this point to be Vx. Okay, for my convenience, because I cannot have it without naming. If it's named, we can use it easily. That's the thing. Okay, this is connected directly to ground. Alright, so this is easy. Done. So this 1 ohm resistor is connected from Vx to ground. So Vx to ground. Okay, 1 ohm resistor is done. And then here from Vx there is 8 volt and 1 ohm. Okay, fine, let's do that as well. 8 volt, 1 ohm, and then ground. Okay, another branch is done. So another branch here, this 1 ohm directly Vx and ground, right? This is Vx and this is ground. So another branch from Vx to ground. Alright, done till here. And this 8 volt is still missing. So 8 volt is from this point where like 5 and 1 ohms are connected together. This point, there is 8 volt. 8 volt is also connected directly to the ground. Okay. But what are we supposed to find? We are supposed to find the current I. What is this current I? The current I is the sum of the currents, these two currents. The currents coming from here and here. Okay. Because that's the way I'm assuming the direction of currents. Okay. So if I assume like that, okay, so let's assume the current direction for all these things. So if it's coming entering current, I'm saying these are all leaving currents. I'm going to assume that way, and I'm going to write the nodal at Vx. So at Vx, if I write nodal, okay, this is 8 volts, right? If this is 8 volts, these are all 8 volts. Why these are all 8 volts? Because this 8 volt is connected directly to the ground. So the effective voltage that will be seen at this point will be 8 volt. So 8 volt, it will be 8 volt till there is any other drop. So it will be 8 volts everywhere. Wherever I'm marking, it's all 8 volts. Okay. So if I write the KCL for this node Vx, it will be for this branch, first for this 1 ohm, top 1 ohm resistor. One end of the resistor is connected with 8 volts, so 8. The other end is connected with Vx, and higher potential minus lower potential. So 8 minus Vx divided by the value of the resistance, that is 1. That's the entering current. Entering current equal to the leaving currents. So leaving currents, so here, let me call the center. So Vx minus 0. Vx, because the other end of the resistor is connected to 0. So Vx minus 0 divided by 1 ohm resistor. So Vx minus another here also, plus Vx minus 0 divided by 1. And when I consider this branch, this is also 1 ohm, right? Okay, this is 1 ohm, this is 8 volts. For this resistor I'm writing, for this resistor, one end is connected to 0. Well and good. The other end is connected to some battery. But is it the effective voltage is 8 volts? No. In this case, the effective voltage is not 8 volts. Why? Because the 1 ohm resistor is connected here. That means effective voltage is not 8 volts at all here. There is a drop because of this resistor, and this is because also there's another Vx. So let me write, I need to find what is the potential at this point. So let me write a KVL and see what would be the potential at this point. Okay, let me mark this as VB. Okay, so I'm going to write a KVL here. So Vx, from Vx I'm writing a KVL. So Vx, and here plus and a minus, there's a drop. So 8 volts equals VB. I'm stopping at VB. So VB is what? VB is Vx minus 8. So now I can write the potential at this other end of this 1 ohm is VB, and VB is Vx minus 8. So Vx minus 8 divided by 1 ohm. Alright, so let's keep this aside. Okay, I just want to mark it and keep it. Okay, that Vx minus 8 only we are using it here. Okay, fine. So now we can solve. Why is it okay here? These are all Vx, correct? Okay, we can solve for Vx because Vx is the only variable need to be solved. Okay, so everything denominator is all 1, so no problem. I'm taking all the Vx to one side. So if I take all the Vx to this side, it will be 2, 3, 4 Vx. So 4 Vx equals, so 8, this is 8, and 8 plus 8 will be 16. So Vx happens to be 16 by 4, that is 4 volts. Okay, I just found Vx, haven't found everything. I need to find what is I. I is the current, sum of the current through 1 ohm and the 8 volts branch. This current plus this current, that will be my I. The current I will be this. That is flowing, the sum of these two currents. Okay, flowing through 1 ohm and 8 volts. That will be my I, right? So that is what I need to find. So what is the current of this 1 ohm resistor? So I'll call that as be I1 ohm. I1 ohm is V by V minus 0 by 1 ohm. So the KCL for this branch is V minus 0 divided by 1, right? So this V is Vx. Okay, Vx is 4 volts. So 4 minus 0 divided by 1. So that happens to be 4 ohm, 4 amperes, 4 ampere current. 4 amperes of current. Okay, that is current through 1 ohm. And then the current through your 8 volts. Here I need to find. But this is not a resistor, so we cannot find directly. So we have to write a KCL for this branch, or sorry, KCL for this node. So I know directly the current leaving is 1 ampere currents. So here let me choose some other color. Okay, this is 1 ampere current. Why? Because the current source is in series. So 1 ampere current will be flowing this side because of this current source. See, a series circuit, same current will be flowing, so it's a series path. The series path, the same current 1 amperes will be flowing. Okay, this is 1 amperes I know. This current if I know, the downwards current if I know, I can say the current here, right? So here if I write the KCL, let me write the KCL for this point, let me call this as VP, okay? Just for the naming. So at VP, we have 1 ampere leaving current. Okay, I'm assuming everything to be leaving current here. So entering current is 0. So 0 entering current equal to all the leaving current. One is 1 amperes. The other one, the downward current is, this is VP. VP is what? VP is equal to 8 volts. So 8 minus Vx. Vx is 4 volts divided by 1 ohm. Okay, this numerator is in volts and this is ohms. Okay, equal and then plus again one more leaving current, that is 8. That I do not know, that is what I do not know, so that is I question mark. I call it as I question mark. So now I can say I question mark will be equal to the negative of all this minus 1, and this becomes 4, so it becomes minus 4. So I question mark is minus 5 amperes. Okay, so now the total current, the current that we need to find is I equal to I1 ohm plus I question mark. So I1 ohm was 4 amperes and I question mark was minus 5 amperes, right? So totally it is minus 1 ampere current is flowing here. The minus 1 ampere current is I. So I happens to be minus 1 ampere current. And that's all for this video. Let's continue the next session. Thank you.